Okay, now we are back to the title slide. Press forward
Mm,
again.
So I'm having like presenting. So I'm having trouble in presenting. So like the slides are
Why
not
don't
changing.
you, Priyam, why don't you do?
Okay,
Oh, yes, yes, it has come.
okay, it's coming. Go ahead.
So these are the overviews. Like first of all, I'm talking like introduction, and I'm talking about the working principle, and then types of work, like types of wireless power transmission, then some history of wireless power transmissions and applications of wireless power transmissions. So, what is power transmission? wireless wireless power transmission is the transmission of electrical energy from from a power source to an electrical load across an air gap using induction coils. And these coils produce an time-varying electromagnetic field which sends energy from a transmitter to a coil or a portable device, that is receiver. Then the receiver takes power from the electromagnetic field and converts it into electrical power and supplies it to an electrical load. The, the technology of wireless power transmission can eliminate the use of wires and batteries. Wireless power transmission is advantageous to power electrical devices where interconnecting wires are inconvenient or impossible, and it is also used to recharge mobile phones, tablets, drones, cars, and many more devices. So, working principle of wireless power transmission. Wireless power transmission works on the inductive power transfer principle as found in the conventional transformers. In general, a wireless power system consists of a transmitter and a receiver. Here, here you can see a transmitter. This is the block diagram of a wireless power transmission, and here first you can see a transmitter device. This is the transmitter device at the left side. This is the transmitter device which is connected to a power source, and this power source is connected to a high frequency alternating current. And this round part of a transmitter is called the antenna, which may be a coil of wire which generates magnetic field or a metal plate which generates an electrical field. This antenna device converts the power to a time-varying electromagnetic field. then, then a similar antenna or a coupling device is used at the receiver to convert this oscillating field to an electrical current, which is then used by the electrical load. Then types of wireless power transmission. So wireless power transmissions has two categories of techniques, that is near field technique and far field technique. In near field technique, the power is transferred over short distance by magnetic field using inductive coupling between coils of wires or by electrical field using capacitive coupling between metal rods. Under near field technique, we have two types, that is inductive coupling and capacitive coupling. The second technique of wireless power transmission is far field technique. in which power is transferred by beams of electromagnetic radiation like microwaves or laser beams. This technique can transport energy over longer distance but must be aimed at the receiver. Under far field technique, we have two types, that is microwave power transmission and laser power transmission. So first we'll discuss about inductive coupling, which is the first type of near field technique. Primary and the secondary coils are not connected with the wires. Power is transferred between coils of wires through mutual inductance. General example of inductive coupling is a transformer. So, here, this is the block diagram of inductive coupling, and um, this is this left side of this diagram. This part is the transmitter coil or primary coil, and the right side is a receiver coil or a secondary coil, and they together form a transformer. An AC through the transmitter coil creates an oscillating magnetic field. Here you can see the transmitter coil is connected to a power source, and the source is alternating current, and it creates an oscillating magnetic field. This magnetic field, the green lines, is the magnetic field, passes through the receiving coil, and it induces an alternating EMF, which creates an AC in the receiver. The induced AC may either be driven directly to the load or be rectified to DC by a rectifier in the receiver, which drives the load. Then, resonant inductive coupling. So, by name you can make out is the combination of inductive coupling and resonant. It is a form of inductive coupling in which power is transferred by magnetic field between two resonant circuits, one in the transmitter and one in the receiver. Each resonant circuit consists of a coil of wire connected to a capacitor. The two resonant circuits are tuned to resonate at the same resonant frequency. Then the resonance between the coils can greatly increase coupling and power transfer. That's why we use resonant inductive coupling instead of inductive coupling, because of the resonance, the power is greatly increased, and it can be transferred to a longer distance. Then capacitive coupling, which is the second type of near field technique. In capacitive coupling, which is referred to as electric coupling or and conjugate of induction coupling, here energy is transferred by electric fields between electrodes such as metal plates. Then the transmitter and receiver electrodes from a capacitor, and with the intervening space as the dielectric, and then an alternative current voltage generated by the transmitter is applied to a transmitting plate, and the oscillating electromagnetic field induces an alternating potential on the receiver plate by electrostatic induction, which causes an alternating current to flow in the load circuit. This is the block diagram of the capacitive coupling. So, this is the first microwave power transmission, which is the first type of far field technique. Uh, in microwave power transmission, high, high power is transferred to a long range distance. Two places being in line of sight usually. AC cannot be directly converted to microwave energy, so it is first converted to DC. Then DC is converted to microwave using magnetron. Then these transmitted waves are received by retina. Here you can see the block diagram of the microwave power transmission. This block diagram of microwave power transmission, it consists of two sections, that is the transmitting sections and the receiving section. So in the in the transmission section, in the transmitter section, the microwave power source generates microwave power, which is controlled by the electronic control circuits. The waveguide's circulator protects the microwave source from the reflected power, which is connected through a coax waveguide adapter. The tuner contains the impedance between the microwave source and the transmitting antenna. Then, based on the signal propagation direction, the signals are separated by the directional coupler. Then, the transmitting antenna emits the power regularly through free space to the receiving antenna. In the receiving section, the receiving antenna receives the transmitted power and converts the microwave power into DC power. The filter and the impedance matching circuit is provided for setting the output impedance of signal source, which is equal to rectifying circuits. These circuits consist of a Scotty barrier diodes, which converts the received microwave power into DC power. Then laser power transmission, which is the second type of far field technique. Laser is used to transfer power in the form of light energy. Then transmitted laser light is received by the photovoltaic cells, that is the solar cells, that converts the light into electrical signals. Usually it uses optical fiber cables for transmission. In the case of electromagnetic radiation, closer to the visible region of the spectrum, power can be transported by converting electricity into a laser beam that is received and concentrated onto photovoltaic cells, that is the solar cells. This mechanism is generally known as power beaming because the power is beamed at the receiver that can convert it into electrical signal. At the receiver, the transmitted laser light is received by the photovoltaic cells that converts the light into electrical signals. The history of wireless power transmission. It's not presenting.
The problem, Priyam, you
Yes,
are
sir.
muted. You
Yes,
are
sir. It's
muted.
lagging, sir.
Press forward again. It came up briefly, and I think you pressed back. Just press forward again.
Yes, sir. I'm lagging. It's lagging too much, sir.
That's fine.
Are you at the end of your presentation?
Yes, sir.
Then without slide also you can conclude. Without slide, you try to conclude by saying in words.
Okay, sir. In history of wireless power transmission. In 1865, Maxwell's theory of electromagnetism was published, which mentions electromagnetic waves moving at the speed of light, and concluded that light itself was just a wave. In 1886, Hall performed a successful experiment with pulsed wireless energy transfer. He, he produced an apparatus that produced and detected microwaves in the UHF region. And Tesla also performed this experiment in the field of pulsed wireless energy transfer in 1899. Then Tesla's magnifying transmitter, an only type of Tesla coil that measured 16 meters in diameter, could transmit tens of thousands of watts without wires. Then Tesla managed to light 200 lamps without wires from 40 kilometers away, although no documentation from Tesla's own reports were even published. In 1901, at Surham, New York, he attempted to construct a large high-voltage wireless power station now called Cliff Tower. But by 1904, investment dried up and the facility was never fully operational and was not completed due to economic problems. Then these are some applications of wireless power transmission. Near-field techniques is the most widely used wireless technology. It's used in charging handheld devices like phones, electric toothbrush, induction cooking, and wirelessly charging in implantable medical devices like pacemaker. The largest potential application of microwave power transmission is space solar power satellites. Wireless power transmission is used in moving targets like fuel-free electric vehicles, fuel-free airplanes, fuel-free rockets, and moving robots. Other applications of wireless power transmissions are wireless power source, RF power adaptive rectifying circuits, and wireless sensors. Thank you, and here are my references.
Thank you, Priyam.
Thank you, sir.
Any questions from the students? If you can't use your microphone, you can also type out your questions in chat, and I'll read them out. Satyan sir, do you have any questions for Priya?
Yeah, Priyam, do you have a thorough idea about mutual inductance, self-inductance, resonance, AC circuit? What is
Yes,
the
sir.
value of impedance? Have you studied all these things in electricity?
Yes, sir.
Ah, the function of an antenna in electronics,
Yes, sir.
it was there in your syllabus.
Yes, sir.
Okay. Now, apart from your wireless microwave transmission, can I ask a question that what is the difference between impedance and resistance?
So impedance and resistance.
Yeah.
Yes, sir. Like resistance, it only occurs in like in DC circuits, and impedance it occurs in like AC circuits, sir. And for you can
Now,
say like
what is the extra thing? What is the extra thing in impedance? Resistance can be connected to AC as well as DC. Say, for
yes,
example,
sir.
we are considering an AC circuit.
Yes,
So,
sir.
in an AC circuit, resistance is also there. You are uttering impedance. What is the extra thing due to which you call it impedance? In spite of the fact that resistance is there.
Yes, sir. So like so impedance is the combination of resistance
And
and inductive reactance uh, or capacitive reactance, sir.
okay, 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 got the point.
Yes, sir.
Anyway,
Well,
this was my question only to know that whether you have studied it or not. And regarding Maxwell's equation, the first you have given the reference. Have you seen the Maxwell's equation somewhere in any
yes, sir.
form? Seen?
Yes, sir.
Where can you tell me? Maxwell's
Um,
electromagnetic wave equation. Small part you
uh,
might have studied. Small part you might have studied.
so Lorentz force, sir.
Maxwell's equation for in
Uh,
electromagnetic.
so in last semester, I studied that Lorentz force.
Okay, if you have studied, then it's good. I don't think that all the four equations you have studied, a part of this you might have studied. Okay, this
Yes,
is
sir.
my question. And regarding wireless transmission, I think many of the things are not within your syllabus, but however, the application part you can highlight. This much from my side. Okay, thank you. Go ahead.
Thank you,
Anybody else?
sir.
Thank you, sir. So Bhaskar had a question. Priyam, can you go to the slide with the laser power transmission?
Yes, sir.
Yeah, so on the third, oh, no, no, go. It says usually it uses optical fiber cables for transmission.
Yes, sir.
Bhaskar wants to know if this is technically wireless power transmission if you're using optical fiber cables.
Uh, sorry, sir. Like I didn't got that last part, sir.
So the idea behind wireless power transmission is that it's transferring through the air or like through the atmosphere, right? But
Yes,
if
sir.
you're using if you're using optical fiber cables for power transmission, how does that become wireless power transmission?
So this optical fiber is only used for for transmission, sir. It's only only used for transferring this energy, sir.
In both the cases, energies are being transferred. Even if you do not use optical fiber, then also it is energy.
Yes,
Even if
sir.
you the question is, if you use optical fiber, will it be called wireless transmission? That is the
Yes,
question.
sir.
Why?
Yes, sir.
It is not wireless then. It is with wire.
So like uh, then
Idea should be very clear. Wireless means no connecting wire in between. And if there is some connecting wire in between, then it is not as wireless transmission, but it is a transmission, no doubt.
yes sir,
You can increase the energy flow, you can
yes sir.
decrease the energy flow, whatever it may be. But things should be clear that whether it is wireless or with wire. Anyway, go ahead.
Uh, Now, I might be wrong because this is something that I read quite a while ago. But if I remember correctly, the transmission between the sender and the receiver is wireless. That is, it's using laser light. But once the
Yes sir,
receiver receives it, it sends a signal through an optical fiber.
yes sir,
Yeah, that's how you should be explaining it then. So, Bhaskar, for in answer to your question, they are using optical fibers after they receive the
yes sir.
power through wireless transmission.
So ultimately, it is not the optical fiber which is connecting the sender as well as receiver.
No, sir. It's just
Optical fiber
after
will
the
be at the
receiver. Yes,
receiver,
sir.
receiver's end. Yeah.
After the receiver receives it, then they send it, use the
Yeah,
optical
yes.
fiber for their purposes.
So it's
Also,
a sensor, sensor.
yes, sir. Also, Priyam, since you're on the slide, as Sujata ma'am pointed out, there's a mistake in photovoltaic cells. Can't have spelling mistakes in your presentation. Anyway, Pradul sir, any questions?
Yes, Priyam, it's a very good presentation. We are at least now confident with the second and the third years that now you have at least a fair idea to give presentations. And I'm very much impressed to see your presentation overall. It was a very good and elaborate presentation. Okay, so this we were talking about this optical fiber cables. No, so this is also I think they are developing a Li-Fi technology. So just like wireless fidelity, we'll
Yes
also be
sir,
having this Li-Fi technology. So where optical fibers will be used to communicate, I mean, transmit the signal. So you spoke about wireless power transmission. Okay, so it sounds very interesting and very futuristic. So this means that basically, if I have a mobile device, I don't need a battery, so I just need to have a wireless power transmission source at my home. I can move here and there, and my device will get connected. I don't need wire, no?
yes sir,
Acha. So it is using microwave to transmit the power to my device, right?
yes sir.
So we don't need plugs, switches here and there. So everywhere there will be power, and all the electronic devices can use that power through air, right?
Sir,
Is that true?
yes, sir.
With
Sir,
the
I didn't.
with the wireless power transmission, I do not.
Yes sir.
Of course, if it is consistent and if it does not die out, I will not need batteries for my electronic device. No, it will get instantly connected to the power. No, just
Yes
like
sir. Like
to electrical socket.
yes sir. In the like in microwaves, power transmission. So like we are like the line of sight is like always uh, like in so like in it's always in the line of sight, sir. Like two places, like microwave in microwave power transmission, like the it's always so it's directly like we have to point out to the receiver, sir.
Acha. So what if
In,
I have got two separate compartments at my home room, two separate rooms. At one
yes,
room
sir.
there is my wireless power transmission system. If I go to another room, will I be able to charge my device?
Sir, in like if you if you're charging an electronic device and you'll use this power transmission, wireless power transmission, then it only have a sort of like certain range, you know, sir. Like in
It will be blocked. No?
like
Microwaves usually should be at the line of sight, isn't it? So that's why in
yes,
case
sir. But that is for like far field techniques, sir. Like for near field techniques, you need to be in the range, sir.
just like Wi-Fi.
Yes, sir. In the range, yes, sir. In the range of the field, magnetic field, sir. Yes, sir.
Okay, but we know these microwaves are harmful, no? You have seen that microwave oven at home also when you put the food
Yes, sir.
inside it gets heated. So how are we eliminating this with the help of WPT?
So like how are eliminating
Is there no danger
microwaves?
of this heating effect just like in microwave oven?
Or like heating. So you're asking about heating,
Hmm.
like how this if affect us,
Doctor, Doctor,
Yes, yes. Is it not
ডাক্তার
harmful?
বলেছে
Because
কিনা মাকে প্লক
this
কাটতে মানা করতে
wireless power transmission technology, because it emits microwaves, okay, and
yes sir,
microwaves are harmful, no, because it has heating effect.
yes sir, yes sir. This microwave radiations it usually hits body tissues the same way it hits the food, sir.
Yes, that I understand. But if I have this technology, it will be charging my phone also, and it will be heating my body also. That is that correct?
Uh, when you use this microwave radiations, like microwave for transmission, it only as I said, it's always in the line of sight, so it is directly charging the object, but uh, small radiation which is released in the air, it usually affects our body, sir. Like
Acha.
it hits about body tissues, but at limits,
In this wireless power transmission system or whatever cellular microwave signals that we are receiving, they ensure
yes
to
sir.
use very, very low power. Okay, so it's
O-
the power that decides how harmful it is to us. Okay, also the
okay sir.
frequency. So the microwaves, the usual microwave oven that we use at home, the frequency
Yes
of
sir.
that microwave is it at resonance with the water molecule. Okay, so once it is incident on the water molecule, it gets excited and that heating effect is there. Okay, so this day-to-day technologies like the cellular communication network and this wireless power transmission technologies, they try to avoid it by using low power and offset the frequency that is in resonance with the water molecule that is present in every other object. Okay,
Okay sir.
okay, thank you.
Thank you sir.
And thank you, sir. Sujata ma'am, any questions? Sujata ma'am, any questions? Oh, mic is not working. Okay, ma'am, you could be typing out the questions. I'll just ask Digvijay sir if he has any questions when ma'am is typing it out. Digvijay sir, any questions?
Okay, Priyam.
Yes
So
sir.
you have like in laser transmission,
Yes sir.
yeah. So what kind of lasers are used for the transmission? Like
What kind of laser, sir? Uh, so I just read out of lasers, sir. Laser beam,
I think Priyam
general
won't be able
lasers.
to Priyam won't be able to answer because type of lasers and other things should be taught separately. One
okay,
should learn separately whether
Sir,
there is or not laser or not.
I
He
just
might
learned
have, he
about.
might have, yeah, yeah. Priyam
So
might
I
have read
just
that laser, only laser
yes, a
light.
laser. Yes, a laser beam which is just close to the visible region of the spectrum, sir.
okay,
Okay, that's
visible
right.
range.
That's right. But Digvijay sir is asking what type of laser you are using. But you are not using this thing. You do not have any idea, details about the laser generation and other things. So apart from this thing, Digvijay sir may ask question because details of the laser they might have not studied.
Okay, in the like you in the near field uh, power transmission, right?
Yes, sir.
So in you used the term like inductive and capacitive, right?
Yes, sir.
So, so in the working, like just simple working, how is inductive method different from capacitive method?
So in inductive, you use magnetic field concept and magnetic field, uh, and in capacitive we use electric field. So uh, I mean to say like Okay, so it's like in inductive coupling, so like when in the inductive coupling, like when AC is passed through the transmitter coil, sir, an oscillating magnetic field is created, while and this magnetic field like passes through the receiver coil and it induces an alternative like EMF, while in the like well, in the capacitive coupling, sir, uh, like energy is transferred, sir,
No, I mean I didn't
like
understand like where the inductor or where the capacitor is used. Like where is it used? I
so
couldn't understand
You
that part.
should know details of the electrical circuit.
No,
Details of the
just
electrical circuit knowledge is necessary here.
sir,
like where in what component, like either the receiver or the sender is using which where is it used actually, the inductor or the capacitor?
also inductor or the capacitor.
No, I mean like yeah,
So
in that.
so like in the like you mean to say like what is like inductor or like
No, no,
or
like I mean like in your in your wireless transmission. So where
yes, sir.
is an inductor used in the like in the receiver end or the sending end?
No, no, sir. I'm not using any inductor. Sir.
But it specifies, you specified it like inductive method, no?
Yes, sir. But because like the EMF is induced.
Okay, okay. Maybe Bikramjit sir can ask. I'm okay.
Okay,
Yes,
so
sir.
Sujata ma'am, is your mic working now?
Yes, ma'am.
Yes, ma'am.
Okay, so Priyam, in your that slide, that in optical fiber slide, at first I
Yes, ma'am.
thought that you did mistake. You did typing mistake. Photo you wrote photovoltaic.
Yes, ma'am.
Yeah. At
Yes,
first,
Photovoltaic.
ma'am.
yeah. But later I noticed that you used later also this word, but you pronounce that photovoltaic. Okay, so
Yes, ma'am.
you should know that it is not photovoltaic. It is voltaic.
Voltaic, ma'am.
Yeah, voltaic.
VOLTAIC,
VA.
ma'am.
Yeah.
I see. Yes, ma'am.
Okay, so and do you know about the efficiency for this type of wireless power transmission? How much is the efficiency?
Efficiency, ma'am, above
Just a minute.
efficiency. I just read it, ma'am. It's above 90 percentage. Like
Yeah, it is above 90%. And do you have any idea how can we increase that efficiency?
how, like if ma'am, like efficiency. I just know about this inductive coupling, ma'am. The efficiency is increased by resonance out there, and that is the resonance, that inductive coupling. I just know that, man.
Okay,
I,
okay, okay. It's okay. So over to you.
Thank you, ma'am. Okay, Priyam, I won't ask you too many questions. I know we're in the middle of the break, and and you can ask quite a few questions. One last thing, in the applications for wireless transmission, one of them you mentioned was space solar power satellites, right?
yes, sir.
I think
Yes,
the
sir.
idea is you collect solar power using satellites and then transmit that power to Earth using microwave transmission, right?
Yes, sir.
Is that how it goes? Okay. Do you know where you sourced that data from, like that idea from? Do you know where the source is?
Sure.
So the reason I'm asking is
What
I don't.
source?
Yeah. So the reason I'm asking is not that I think that you're wrong, but one of the issues with microwave transmission in the atmosphere is that the atmosphere happens to be a very good conductor of microwaves. This is why
Yes.
when we do our microwave experiments, like the cosmic microwave background experiments, we put our instruments above the atmosphere, either on a balloon or on a satellite. Now, there are
Yes.
ground-based microwave experiments. Polar bear is an example of that. But the atmosphere causes havoc, which is why I was curious about about transmitting power using microwaves. So I just want to check that source. I don't think you like. I'm not saying there's an issue with you. I want to see what the source is saying about the efficiency of this method. Anyway, other than that, it's a pretty good presentation. I like the energy in your voice. Like you had a good amount of energy in the voice. And I could see that you're using those animations. You're putting you're making the bullet points come up one at a time. Now, unfortunately, because of the internet connection, there was some lag and it was not coming out as clearly. But you were
Yes.
using the animations, which is good. I like that you were showing things piece by piece instead of showing everything as a whole. One feedback I'd give you is you were putting the diagram at the bottom of the slide. Don't put it at the bottom of the slide. Make it the top of the slide. Usually, people like looking at diagrams instead of bullet points. You might want to put it in the top of the slide because most of the time you're explaining what's going on the diagram anyway. So you might want to start by showing the diagram and then next you put the bullet points.
Okay, sir. Thank you,
Okay.
sir.
And
Okay.
your physics thing was good. Obviously, you got asked a lot of questions. So now you know that you need to do your prep on your research. Everybody knows they need to do some amount of prep on your research. You will be asked questions about the basic physics. Yeah, aside from that, it's pretty good. I like the setup of the PPT as well. As the setup was fine. Your PPT was not distracting. Everything was in place. Yeah, but you do need to do some more prep in answering your questions. But everything other than that, it was a pretty good presentation. Thank you, Priyam.
Thank you, sir.
Any feedback, Prajul or anybody else?
No, sir.
Prajul sir, any feedback? I think Prajul sir might be disconnected because of his.
Maybe.
Yes, sir. Okay. If sir, your microphone is muted. Prajul sir, your microphone is muted.
Oh, am I audible now?
Yes, sir.
Oh, sir, no, sir, I am happy with the way they have presented the slides also, and as well as the energy that they have put in to deliver the contents. Especially, it seems like Priyam and Aranjali have dedicated a substantial amount of time to make this presentation. It's a very great effort that they have put in, and congratulations.